So, brief introduction to FSharp. FSharp is an open source cross-platform functional first programming language from the .NET platform. For example, the guy that created the language was the guy that implemented generics in C#. And if you follow the evolution of C# and F# you will see that a lot of the things that are being incorporated to C# come from FSharp. For example, async, or now tuples, or a less difficult kind of defining tuples, pattern matching a little bit. So, and it's cross-platform, so you can develop from a Mac, from Linux, from whatever. You don't need Visual Studio. You can do it with Atom or Visual Studio Code, or whatever. And it's a very nice language. Let me show you. So, can you see something? Or what is the presentation mode? It's okay, the size of the font? Yeah? So. I don't know what is worst. Well, this thing that you can see in the right-hand side is the FSharp interactive. So we can send comments to the FSharp interactive window, and it will be evaluated. So, for example, or we can write it like here directly. You know, for example, if I say A will be 5. So now we have a value called A that is an integer and has the value of 5. So as this is a functional functional language, so functions are quite important. As you can see, this is how we define a function in C#, curly braces, types, return, sorry. And here is how we define the same function in FSharp. So we don't use curly braces, we use spaces. So spaces are important in FSharp. So if I want to put this piece of code in another line, I need to put some spaces here. FSharp is using type inference so it's strongly typed, FSharp, very strongly typed. And it has a powerful type system, and type inference works really, really well. So he's inferring that we're going to use ints because the simplest type that has some. If we want to specify the type, something like that, no? So colon and float. So now the type system is inferring that B should be a float because A and B should be of the same type. As you can see, we don't have the return word. So the last line of a function is what we are going to return. And in FSharp, there are no statements, there are only expressions. So everything returns something. We're going to delete this type here. And now this code is going to. So here we have a function that gets 2 integers and returns an integer. Okay, if you're using whatever, because I think Ionite works the same way on Atom and Visual Studio Code, to send a command to the FSharp interactive, this is Alt-Enter. So Enter. More things about FSharp. We can define tuples. Tuples is an aggregation of values. Can be 2, 3, 4, or whatever. So here we are defining a tuple of a string and an integer. So you can see a string and integer. We can decompose this tuple in this way. So this is the simplest pattern matching that we can use to decompose a tuple, and we're decomposing this tuple in the value year and in the value name. we can have a function that receives a tuple. Here we are saying that we don't care about this value. We're not going to use it, and we just want to decompose the year, so we can return it. So now if we call this function, we can see that year is equal to 2016. We can make something similar with functions already existing in the system, like it's second and first. There's no third, so it only works with second and first, but we can use these functions. Apart from tuples, we have types. You can think about types like structs or classes. Here we are defining a type conference with a name and a year. In C#, this should be something similar to a class with two properties with private setters and one constructor with two parameters, name and year. And here we just have a one-liner to define a type of this, or value of this type. We just use this. Well, we just specify the name of the different properties. And in FSharp, by default, all is immutable. So if we want to create a kind of copy of this value, but not having to use name equals LambdaConf 2016.name, blah, blah, we can use this kind of expressions. So we want this value, but we want to change the year to 2017. So now LambdaConf 2017, it's the same as the previous value, but with the year changed. As usual, we have a partial application. Remember that we had a sum that takes two parameters and returns the value. And here we are defining a new function that takes one parameter and applies the sum function with one as the second parameter. So we are always adding one to the value, and the same with two. So you take a look. Here we have the add one function that takes an integer and returns an integer, and we apply this function to the number 3. We're going to get 4 as a result, and if we take the add 2, we're going to have 5 as a result. Quite important thing in FSharp is the pipes. So what's the pipe operator, which is this vertical bar and the greater than? What it's doing is just applying this parameter on the left-hand side to the thing on the right-hand side. So if we, instead of doing that, we can do these kind of things as we did before. So instead of doing these kind of things, we can do these kind of things. And this is useful for readability and sometimes or we will use it a lot to kind of define different steps that, for example, a collection, we want to filter and we want to fold and we want to map, etc. We can start with the collection and then apply all the other operations. Something a bit similar is function composition. So we can compose two functions. So what are we getting here is a function that takes an integer and returns an integer. So the thing that we are going to pass here, we are going to apply first to the add one, and the result of that one we are going to apply to add 2. So we can define an add 3 function that when we use it, we get 6. Then we have the discriminated unions. You can think about discriminated unions like an enum, but it's a much powerful thing than an enum. So it's a discriminated union is a type that can only take one of the possible values. No? For example, if we take a look at the type conference, we can have a lot of conference, no? Because we can have a lot of variations of the name and a lot of variations of the year. But when we work with a discriminated union, we can have only one possibility. It can be a sum, or can be none. In this case, because it's the option discriminated union.
Quick question.
Yeah.
So in the function composition,
yeah.
When you have add one into add two, is that add two composed of add one, or is it add one composed of add two? That's composed of G or G composed of.
So we are going to apply the parameter that we're going to pass to add 3. We are going to apply add 1 function first, and the result we're going to pass to add 2.
So passing like patching 3 into the
exactly. So 3 plus 1.
Exact same thing essentially that we did in the Lambda.
Yeah.
Okay. Thank you. Sorry.
No, it's okay. You can stop me when you need. So discriminated unions. In this case, is the option type, which is the discriminated union that has some and none. So instead of returning nulls, we don't have nulls in FSharp. Well, we kind of have nulls, but just for interoperability with C#. But if you write just FSharp code, you don't have nulls. So for defining a value that can be something or no, we can use the option type. So we can have some of hello or integer or whatever, or none. And we can pattern match this discriminated union. This is a powerful technique. So we can match, for example, S, discriminated union, with the different types, different options, sorry. So we have, if it's sum, we can capture the value of the option in the value X, and then we can print X. And if it's none, we don't have value, so we cannot capture any value, and we just print none. So if we execute this code, you can see that we're printing here hello because it's the sum is S. If we apply the same code but to the other one, the known, we are going to print none because we are in this path. In FSharp, we are not allowed to. You can think of pattern matching as a kind of switch as well, but you cannot leave any case without being evaluated. So if we do this thing, we are going to have an error, or in this case a warning, because the pattern match is incomplete. In case that you want to specify the default behavior, you just the same as before, print, sorry, whatever. So that means that this is all the other cases. This is another handmade discriminated unions, for example, figure that can be a circle or a rectangle. And to create a value, we just use this notation. And obviously we can pattern match, we're going to see. But we cannot just specify that this is a circle and this is a rectangle. We can specify what kind of thing is a circle and what kind of thing is a rectangle. That can be different things. For example, in this case, we have a circle that it's a thing that it's a radius. That has the value of the radius. And instead the rectangle has a width and a height. So actually both figures are kind of different, but we are storing them in the same discriminated union. And now if we want to create a rectangle, we just do this way. We can pass and we can name the properties to be more clear. And obviously we can pattern match, and when we pattern match, we can capture the radius in this case or the width and height in this case. So if we execute this code, F was a rectangle, so we are printing rectangle with width and height. Collections, we can create collections easily. This is to create arrays. That is what we are going to use in this workshop. So we are here specifying just the values. Here we are specifying that we want values from 100 to 120. As you can see, from 100 to 120. And here, more or less the same, but the steps are the step of 3. So we have 100, 103, 106, blah, 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 until 118. Or we can create the numbers from an expression. For example, 4 or a more complicated function that you can think about. So here, for example, we're just doubling the 4. Here I let you a lot of functions just to don't need to go to internet while you are developing the exercises. So you can see how a map works, how map I works, iter_i, filter, choose. So you're going to use filter, you're going to use map, you're going to use probably sum, you're going to use choose, sort, or sort by descending. We're not going to use reduce or fold here. But collect, for example, we're going to use collect. Collect is like the select many in LINQ. So we have an array of arrays in this case, and we're collecting all these arrays in just one array. Okay, so basically for reference you have here this the methods of the array model. And finally, something quite powerful of FSharp, and we're going to use it as well, is the type providers. Type providers is a thing that gets an abstractor data, like can be a CSV, and it converts it to a type that in compiling type in time you have type safety. So you have strong types. For example, let me show you the example. So here we are loading this CSV, which has name, surname, and city. And when we create the CSV provider, and we provide an example of the data that we want to parse, in this case, first name, last name, and city, then we load the data that we want to load, in this case, this example, test CSV. And finally, when we get a row, compiling type, so now, without debugging, without building anything, when we access the row, I have city, first name, and last name. So I cannot make a mistake accessing a property that the CSV doesn't have. So it's quite awesome. And there are tons of type providers to access database, to access whatever. But in our case, we're going to use the CSV provider. Cool. This is a very, very, very quick introduction to FSharp and things that you are going to more or less use in the exercise. Obviously, I'm open to questions when you were developing the tool. Yeah?
About the array functions that you were calling there,
yeah.
Do you have to say array dot, or can it infer that?
Sorry? No, it's a higher order function, so you have to call array dot. So, come on. So, for example, filter. So it takes the function that you want to filter as the first parameter and the array as the second parameter.
So you need to say array dot filter. You can't just say filter.
No, you need you need to specify the module. So all these modules all these functions are higher order functions that takes the function and the thing that you're going to apply that function. So the tool. Well, anybody has read this book? No? So well, I recommend you to read it. Your code is kind of seen from Alan Thorhill. And so the thing is that we have some tools to evaluate or to assess the kind of quality of our code, no? Complexity and so on. But a lot of these tools doesn't use the history of the code, just use a snapshot of the state of your code when you are applying the tool. But we have a place when we have all the history of our code, and we can try to extract information from that source, and that source is the code repository. So we are going to see some operations that we can create, and we can, in our case, we can develop in FSharp to extract information that we can use in our workday. For example, to see where I need to refactor something, or to see if someone leaves the company, which files this guy has the more knowledge on them. So he has to explain us a lot of things about before going out. Or for example, if we have some hidden relationships between classes or between packages or whatever, not directly referenced by code, but for example, if we commit 2 files so every time we commit the 2 files at the same time, maybe we have there some kind of relationship that we are not aware and we want to solve. So that's what we are going to do today. So let's start working. So you have the last version of the code. What you have to do is open. You can have the demo to take a look at the operations. Yesterday I pushed the solution in case that you need to take a look at the solution of the exercises. I'm not expecting to do everything in just 1 hour and a half, but here you will have the code in case you need. And this is the script that you will have to finish. So every point has the explanation of what we're going to do and a bit of just starting. So remember that in order to run this piece of code, the first thing that you have to do is run these files. So run these lines, sorry. These lines are going to, oops, come on. Oh, sorry. There's an error here. I'm so sorry. This should be Nancy, not SFA log. Okay, so when we execute these lines, this is what we're going to see at the end of the code. So what I'm doing here is just parsing the log file of the Nancy project, the Nancy FX project of the .NET. It's a kind of MVC. So here you have all the commits that has been made to this repo. And the commit is a list of commit infos that has a hash, an author, timestamp, and a message, and a list of committed files. It has the lines added, the lines deleted, and the file name. Yeah? Cool, let's start with easy things like basic statistics, and let's start with calculating the number of files changed the number of files that has the repo has, the files by type, so how many CS files I have, how many JS, etc. We're going to start charting or plotting this kind of information, so we are going to see something like that. Sorry, something, yeah, like that one. Number of lines, all these kind of charts we're going to do. And finally, the authors that have committed something to the repo. So hopefully you have all you need to start. If you have any questions or whatever, please ask me. You can take a look at the solution file if you need as well. And let's start. Until we have kind of 20 minutes until the break. In this first section, you have the expected results that we are expecting, and in case that you don't want to work with the Nancy and you want to work with your own repo, hopefully you can do that. If you go to the solution, no, sorry, it's not here. Well, you just have to recreate the log. Let me look for the command, but it's just create a log. Let me take a look.
Where is all this? Where's the repo? Where all this code?
Yeah, the repo is here. So it's github.com/VGALTES/LambdaConf 2016.
The selection for this room, the links are posted.
So you don't see, okay, you don't see the, okay, yeah. So what you have to do, so this is, yeah, so you can see the, well, what you have to do is go to slash, yeah, .packet.x install, yeah, let me copy, so come on, yeah, can you see the, so yeah, you have to go to the repo, the exact repo info, and exit this command. Sorry, I'm not saying that in the instructions, which is /.packet/packet.x install. This will download on the reference. It's a kind of package manager, alternative package manager for the net, made in FSharp, and it's pretty good, much better than NuGet. So everybody can execute that. You should have.
Is there a different way for Macs?
Yeah, for Mac should be a next. Sorry. Yeah, but Bootstrap should be in the repo, but it's the X. Sorry. Come on.
Looks like you can just preface it with mono and it will work for Macs.
Sorry?
If you just put mono in front of it, it will work for Macs.
Ah, okay.
Same lens.
Mono in front of what?
If you type mono and then try to execute the exe, it will go.
Awesome.
Cool. Yeah, sorry about that. Yeah, Bootstrap should download the packet.x and then install the packages. Yeah, so with, okay. Oh, okay, yeah, sorry, yeah. Yeah, and then, yeah. Yeah. Yeah, sorry. To be able to have the packet.x, you have to execute first the packet.bootstrap. That one. And then this will download the last version of packet.x, and then you can run the install command. of packages. Yep.
Yeah. Alt and so you have to select what you want to. So you're first of all,
Okay,
thank you.
Cool. Good here.
Yeah.
Yep.
Where it goes to one file. It's this one.
Yeah.
Sorry, I just had to change
Oh, okay, yeah. Yeah.
Is there a concept for OS?
I guess that you can use
Sorry?
Like the city. I got this. It's supposed to show up.
think everything is good. Thank you very much.
Yeah.
I think I raised that now.
So you mean?
Yeah.
So it's 5 to 11. You don't have to make the break if you don't want. I'm going to stay here. Anyone has solved the first one? Yeah. On here. Yeah.
But it comes built in with a lot of stuff, so a lot